Welcome to my channel, The Proper Guidance. Here we are today to discuss chapter number 1 of class 12 computer science, and this is about exception handling in Python. Now see, in this chapter we will discuss introduction, syntax error, exceptions, built-in exceptions, raising exception, handling exceptions, and finally clause. So first part, introduction. What is exception handling? Sometimes while executing a Python program, the program does not execute at all or the program executes but generates unexpected output or behaves abnormally. This situation is known as some exception condition. These occur when there are syntax errors, runtime errors, or logical errors. Okay, these are the errors. If these errors occur in the code, then the program will not execute properly. This is the main thing. Now in Python, exceptions are errors that get triggered automatically. However, exceptions can be forcefully triggered and handled through program code. In this chapter we will learn about exception handling in Python programs. First of all, we will learn about syntax errors. This is very easy. What is syntax error? Syntax errors are detected when we have not followed the rules of the particular programming language while writing a program. Because we all know that when we are doing some programming language, there is a specific syntax for that particular language to write down the code in that particular language, and if we miss something in that particular syntax, it will occur syntax error, and these errors are also known as parsing errors. Okay, on encountering a syntax error, the interpreter does not execute the program unless we rectify the errors. When the interpreter goes through the programming code, it does not execute the program unless we rectify the errors. Without rectification of errors, the program will not run properly. Save and rerun the program. When a syntax error is encountered while working in shell mode, Python displays the name of the error and a small description about the error as shown in the following figure. Look here, this is the programming code here. If marks greater than 20, print good score. Okay, syntax error, missing parenthesis in call to print. Here parenthesis is missing. We know to write down the print statement we have to give a parenthesis, and here there is no parenthesis in that section in the print line, right? So missing parenthesis in call to print. Did you mean print this thing? And this is the syntax error. When we go through this one, we just go to the programming code area and put a parenthesis after print statement, and then again save and rerun the program, and after that it will run properly. Okay, so a syntax error is reported by the Python interpreter, giving a brief explanation about the error and a suggestion to rectify it. Similarly, when a syntax error is encountered while running a program in script mode as shown in figure 1.2, this thing, a dialog box specifying the name of the error and a small description about the error is displayed. Look here, if marks greater than 10, print good score. Missing parenthesis in call to print. Did you mean print this one? And you have to press OK, and after that you have to put a parenthesis in the print statement and rerun, save and rerun it. Okay, now here is the definition of exceptions. Even if a statement or expression is syntactically correct, there might arise an error during its execution. Even if statement or expression is syntactically correct, there might arise an error during its execution. For example, trying to open a file that does not exist, division by 0, and so on. Such types of errors might disrupt the normal execution of the program and are called exceptions. An exception is a Python object that represents an error. This is the main thing. This is the gist of the chapter, that an exception is a Python object that represents an error. When an error occurs during the execution of a program, an exception is said to have been raised. Such an exception needs to be handled by the programmer so that the program does not terminate abnormally. Therefore, while designing a program, a programmer may anticipate such erroneous situations that may arise during its execution and can address them by including appropriate code to handle that exception. It is to be noted that syntax error shown at figures this, but all other exceptions are generated when a program is syntactically correct. Okay. Now, built-in exceptions. Built-in exception means commonly occurring exceptions are usually defined in the compiler or interpreter. These are called built-in exceptions. Python standard library is an extensive collection of built-in exceptions that deals with the commonly occurring errors or exceptions by providing the standardized solution for such errors. On the occurrence of any built-in exception, the appropriate exception handler code is executed, which displays the reason along with the raised exception name. The programmer then has to take appropriate action to handle it. Some of the commonly occurring built-in exceptions that can be raised in Python are explained in the following table. Built-in exception in Python. First of all, syntax error. It is raised when there is an error in the syntax of the Python code. Value error. It is raised when a built-in method or operation receives an argument that has the right data type but mismatched or inappropriate values. I/O error. It is raised when the file specified in a program statement cannot be opened. Okay, like this, there are so many errors built in. Keyboard interrupt, import error, end of the file error, EOF. This is very important. End of the file error, zero division error, index error, name error, all those things are here. Overflow error. Okay, you people just go through this chart and try to memorize all the activities of these exceptions. When the built-in exception is arised and raised in that particular program, you have to go through this chart properly. And now the following figure shows the built-in exceptions: zero division error, name error and type error. You please go through. A programmer can also create custom exceptions to suit one's requirements. These are called user-defined exceptions. So, two types of exceptions are here. One is built-in, another is user-defined exceptions. We will learn how to handle exceptions in the next section. And this is the thing, raising exceptions. How to raise an exception in your program. Each time an error is detected in a program, the Python interpreter raises or throws. These two words are used here. Raises or throws an exception. Exception handlers are designed to execute when a specific exception is raised. Programmers can also forcefully raise exceptions in a program using the raise and assert statements. Once an exception is raised, no further statement in the current block of code is executed. So, raising an exception involves interrupting the normal flow execution of the program and jumping to that part of the program which is written to handle such exceptional situations. So, the raise statement, look here, the raise statement can be used to throw an exception. The syntax of raise statement is raise exception name, optional argument in parentheses. The argument is generally a string that is displayed when the exception is raised. For example, when an exception is raised as shown in figure this, the message oops an exception has occurred is displayed along with a brief description of the error. The error detected may be a built-in exception or may be a user-defined exception. Okay. Now say, consider the example given in this 1.6 that uses the raise statement to raise a built-in exception called index error. Index error. In this case, the user only raised the exception but has not displayed any error message explicitly. Since the value of variable length is greater than the length of the list of numbers, an index error exception will be raised. The statement following the raise statement will not be executed. So, the message no execution will not be displayed in this case. Okay, as we can see in the figure, 1.6 this also, that Python also displays a stack traceback. This is a structured block of text that contains information about the sequence of function calls that have been made in the branch of execution of code in which exception was raised. The assert statement, we will learn about stack in chapter number 3. The assert statement, what is assert statement? An assert statement in Python is used to test an expression in the programming code. Okay, an assert statement in Python is used to test an expression in the programming code. If the result after testing comes false, then the exception is raised. This statement is generally used in the beginning of the function or after a function call to check for valid input. The syntax for assert statement is assert expression arguments. On encountering an assert statement, Python evaluates the expression given immediately after the assert keyword. If this expression is false, an assertion exception, error exception is raised, which can be handled like any other exception. Consider the code given in program 1.1, this use of assert statement. See here, print use of assert statement. This is definition, negative check number. This is the function actually. Okay, this is the function. Assert number greater than equals to 0. Oops, negative number. If this false, this assert statement is false, then actually what happens when this is false, expression arguments on encounter assert statement, Python evaluates the expression given immediately after the assert keyword. If this expression is false, an assertion error exception is raised. Okay, so this is the technique how to use this one. Print number into number, print negative check 100, print negative check minus 350. So this is the complete thing. You just go through this coding section. In the code, the assert statement checks for the value of the variable number. In case the number gets a negative value, assertion error will be thrown and subsequent statements will not be executed. Hence, on passing a negative value minus 350 as an argument, it results in assertion error and displays the message oops negative number. The output of the code is shown in this thing. Okay, next, handling exceptions. How to handle exceptions? Raising exception is clear to you. Now handling exceptions. Each and every exception has to be handled by the programmer to avoid the program from crashing abruptly. This is done by writing additional code in a program to give proper messages or instructions to the user on encountering an exception. This process is known as exception handling. Need for exception handling? Exception handling is being used not only in Python programming but in most programming languages like C++, Java, Ruby, etc. It is a useful technique that helps in capturing runtime errors and handling them so as to avoid the program getting crashed. And following are some of the important points regarding exceptions and their handling. Python categorizes exceptions into distinct types so that specific exception handlers code to handle that particular exception can be created for each type. Exception handlers separate the main logic of the program from the error detection and correction code. The segment of code where there is any possibility of error or exception is placed inside one block. The code to be executed in case the exception has occurred is placed inside another block. These statements for detection and reporting the exception do not affect the main logic of the program. The compiler or interpreter keeps track of the exact position where the error has occurred. Exception handling can be done for both user-defined and built-in exceptions. Okay. Now, process of handling exception. When an error occurs, Python interpreter creates an object called the exception object. This is the first thing. This object contains information about the error like its type, file name and position in the program where the error has occurred. Okay. The object is handed over to the runtime system so that it can find an appropriate code to handle this particular exception. This process of creating an exception object and handling it over to the runtime system is called throwing an exception or raising an exception, which we have already discussed. Okay. It is important to note that when an exception occurs while executing a particular program statement, this control jumps to an exception handler, abandoning execution of the remaining program statements. This is the entire process. The runtime system searches the entire program for a block of code called the exception handler that can handle the raised exception. It first searches for the method in which the error has occurred and the exception has been raised. Okay, if not found, then it searches the method from which this method in which exception was raised was called. This hierarchical search in reverse order continues till the exception handler is found. This entire list of method is known as call stack. Okay, so what is call stack? This entire list of methods is known as call stack. When a suitable handler is found in the call stack, it is executed by the runtime process. This process of executing a suitable handler is known as catching the exception. If the runtime system is not able to find an appropriate exception after searching all the methods in the call stack, then the program execution stops. The flowchart in 1.8 describes the exception handling process. You please go through. An error encountered in a method, create exception object, exception is raised, runtime exception searches for execution, exception handler in the current method, found, not found. There are two cases, right? Found and not found. If found, executes the code catching an exception, and if not found, searches for methods in call stack in reverse sequence forwarding the exception, and again found, then this thing happens. After that, program terminates. Steps of handling exception. Now, catching exceptions. An exception is said to be caught when a code that is designed to handle a particular exception is executed. Exceptions, if any, are caught in the try block, and handled in the except block. While writing or debugging a program, a user might doubt an exception to occur in a particular part of the code. Such suspicious lines of codes are put inside a try block. Okay, every try block is followed by an except block. The appropriate code to handle each of the possible exceptions in the code inside the try block are written inside the except clause. While executing the program, if an exception is encountered, further execution of the code inside the try block is stopped and the control is transferred to the except block. The syntax of try except clause is as follows. Look here. Try : program statements where exception might occur, except exception name, code for exception handling if the exception name error is encountered. Okay. Now we will see a program code snippet using try except block here. Print practicing for try block. Try numerator 50, denominator int input, enter the denominator, quotient equals to numerator by denom, and print division performed successfully. Except zero division error. This is an error. We have already get in the previous chart where all the built-in errors were found with their proper explanation, right? So, print denominator as 0, not allowed. Print outside try except block. So, this is the way we write the try and except block here in program. The zero division error exception is handled here because we are dividing two values are here. We are dividing into two numbers, and if denominator is 0, that is not possible. That's why we handle this particular error. Maybe when we are giving some user input, someone gives 0 as the divisor, right? And this is not happened. Zero division error will be there and denominator as 0 not allowed. So print outside try except block. And if the user enters any non-zero value as denominator, the quotient will be displayed along with the message division performed successfully. This is the vital line as shown in the figure, this one. And so the next statement after the try except block is executed and the message outside try except block is displayed. However, if the user enters the value of denom as 0, then the execution of the try block will stop, the control will shift to the except block, and the message denominator as 0 not allowed will be displayed here. Thereafter, the statement following the try except block is executed and the message outside try except block is displayed in this case also. Okay, these are the lines here after execution. Sometimes a single piece of code might be suspected to have more than one type of error. For handling such situation, we can have multiple except blocks for a single try block as shown in the program 1 to 3. Use of multiple except clause. See here, print handling multiple exceptions. Try numerator, denominator, print this thing, except zero division error, except value error, only integers should be entered. Okay, so we can handle it. In the code, two types of exceptions are handled using two except blocks for a single try block. So this is vital that two types of exceptions are handled using two except blocks for a single try block. When an exception is raised, a search for the matching except block is made till it is handled. If no match is found, then the program terminates. Okay. However, if an exception is raised for which no handler is created by the programmer, then such an exception can be handled by adding an except clause without specifying any exception. This except clause should be added as the last clause of the try except block. Okay, use of except without specifying an exception. See here, except value error, except print this thing. If the above code is executed and the denominator entered 0, the handler for zero division error exception will be searched. Since it is not present, the last except clause without any specified exception will be executed. So the message, oops, some exception raised, will be displayed. Now this is the next topic here, try except else clause. We can put an optional else clause along with the try except clause. An except block will be executed only if some exception is raised in the try block, but if there is no error, then none of the except blocks will be executed. In this case, the statements inside the else clause will be executed. Look at the programming code here. Use of else clause, how it is used here. Print handling exception using try except else. Try numerator, denominator, quotient, print division performed successfully. Exception except zero division error, this is one, and the other is value error, else the result of division operation is quotient. Okay, so we can use the same thing, the division will occur. And after that, our next topic is finally clause. The try statement in Python can also have an optional finally clause. What is this? The statements inside the finally block are always executed regardless of whether an exception has occurred in the try block or not. Okay, it is a common practice to use finally clause while working with files to ensure that the file object is closed. If used, finally should always be placed at the end of try clause after all except blocks and the else block. Look, finally print over and out. Previously the same coding is here, after that finally over and out. In the above program, the message over and out will be displayed irrespective of whether an exception is raised or not. Okay, now recovering and continuing with finally clause. Recovering and continuing with finally clause, what it happens if an error has been detected in the try block and the exception has been thrown. If an error has been detected in the try block and the exception has been thrown, the appropriate except block will be executed to handle the error. But if the exception is handled by any of the except clauses, then it is re-raised after the execution of the finally block. For example, program 1.4 contains only the except block for the zero division error. If any other type of errors for which there is no handler code defined, then also the finally clause will be executed first. Consider the code given this one. Recovering through finally clause. Recovering through finally clause from this is same. While executing the above code, if we enter a non-numeric data as input, the finally block will be executed. So the message over and out will be displayed. Thereafter, the exception for which handler is not present will be re-raised. The output of the program is shown in the following thing. Okay, so after execution of finally block, Python transfers the control to a previously entered try or to the next higher level default exception handler. And in such a case, the statements following the finally block is executed. That is, unlike except execution of the finally clause does not terminate the exception. Rather, the exception continues to be raised after execution of finally. To summarize, we put a piece of code here where there are possibilities of errors or exceptions to occur inside a try block. Inside each except clause, we defined handler. We define handler codes to handle the matching exception raised in the try block. The optional else clause contains codes to be executed if no exception occurs. The optional finally block contains code to be executed irrespective of whether an exception occurs or not. So, this is our lesson, the first chapter of class 12, that is exception handling in Python. We are doing this particular chapter from NCERT study material. You people just go through the entire thing. My class, this first class for class 12 of computer science is completely for those who are the beginners, for beginners level. Okay, so please go through. If there is any problem, just comment me. I will be clarify that particular problem, and after completion of all the chapters, we will go for the practical section, for the programs to be done in practical. So for today's lesson, this is sufficient. You people please practice this chapter. Okay, thank you for watching.